So problems 1 through 34 on page 201. Let's start with a polynomial function. If you have a preference, I'll let you choose. If you don't have a preference, I will choose. Okay, I'm going to look at 20. And the function is denoted by uppercase f of x, negative 1/3 x to the third plus 3x squared minus 9x and plus 2. So this is a polynomial function. I've always tried to show all different types of functions. So that's our first example. Okay, so the question here is, I'm not talking about max min just yet. That's what it says, max min, and graph the function. No. We're taking it slowly. So the only question I'm interested in right now is find critical numbers if they exist. That's our first question, and we'll go through different functions. And then we'll come back to the rest. Okay. So I know that critical numbers come from two possible sources. One of them is when f prime of x is 0. And the other one when f prime of x is undefined. This is a polynomial function. That's never going to happen. There's no such thing. When I differentiate, that function will always be defined. So therefore, I have to find f prime of x. I bring down 3, and that will make this disappear. So negative x squared plus 6x and minus 9. And the only source possible is that negative x squared plus 6x minus 9 is 0. You know me already. I refuse to solve any equation with a negative leading coefficient. So then x squared minus 6x plus 9 equals 0. And knowing that I already tortured you with this, and I'm hoping that you will say, oh, I know, very easy, x minus 3 squared equals 0. So therefore, although this equation has two solutions, they are both x equals 3. X equals 3 is a critical number for this function, coming from f prime being 0. So now, will this become a max or a min? I don't know. We'll come back after we study other functions for critical numbers. We'll come back and we'll analyze that. So will this become a max min? Not yet. We're not there yet. Okay, let's look at another type of function, let's say, a radical function. Let's see what we do with that. Feel free to choose, or I will. Anyone? Is anyone paying attention? Anyone? One student. If one student is paying attention, anyone? You're working on something else, I guess. Okay, well, I'm hoping that you're going to watch this, at least. Yes.
Quick question.
Yes, please.
So, from the previous problem, why did we not include the 2 at the end? Is it the 2 at the end of 9x plus 2?
This one?
Yeah. Oh, okay.
The rate of change of a constant does not exist. I shouldn't say does not exist, is 0. Is that okay?
Yeah, I got it now.
Very good. Good, moving on. Anything else? Anyone? Okay, so yes? Moving on. I didn't hear what you said, Joseph. I know you said something, but I'm so sorry. Sometimes I talk at the same time and I don't hear.
Oh, I said 24.
Oh, you said 24. Thank you very much. Thank you. Okay, perfect. I'm lazy when it comes to, no, I'm kidding. When it comes to choosing, I just want my students to get involved, that's all. Okay, so the same thing, I am asked to find the critical numbers. That's it, not what the requirement is. We're taking it slowly. Find critical numbers if they exist. Fine. Of course, this for me is this. And when we differentiate, I bring down 1/3. I subtract 1 from the power, again 1/3 minus 1. I'm going to write it again, twist it again, times the inner function prime, lucky me, is 1. So this is 1 over 3 and the cube root of x minus 1 squared. Okay. I know that critical numbers come from 2 sources. Maybe I should have written here so that everyone knows what I'm trying to do. Okay. One of them is when f prime of, I have to use the same notation. When f prime of x is 0, not possible here. How come? A fraction is 0 only when the top is 0, but 1 cannot be 0. So the second possibility is when f prime is undefined. But where the function is defined. So we definitely see that x cannot be 1. I can take the cube root from anything on the planet, including 0, but now it's in the denominator, so this is a critical number. So x equals 1 becomes a critical number only if f of 1 exists. Okay, I'll go back and plug it in. It exists. It's 0. Yes. So f of 1 exists. F prime of 1 does not, and that becomes a critical number. So from the very beginning, the domain of this function is all real numbers. It's the cube root. Any odd index can have anything underneath. If it's an odd index, domain all real numbers, and it's done. Okay, let's also choose a rational. I see here rational, and one more radical. And then I don't see any other type of function, so we don't have to worry about anything else. Any other type of function, so we can go back and analyze the rest. Okay, so okay, I will choose, let's say, you prefer 29 or 30? 29. You said 29?
I was going to say 30, but...
30 it is. So I would have chosen 30 myself, if you didn't say anything. Perfect. So again, I have to determine g prime. Same question, find the critical numbers if they exist. So g prime of x. Top function prime, multiplied by the denominator, minus top function times the denominator prime over the denominator squared. Will I multiply? Absolutely not. I will definitely factor out a common factor. This is the common factor. I'm not going to distribute it. The simpler the better. The factored form is the most important one. So I have x squared plus 1 minus x squared. It cannot be nicer. So then it's 2x over x squared plus 1 squared. Excellent. Good. So now I have the derivative. So in the next step, I'm looking at finding critical numbers, and they come from two sources, and I have to check both sources for any function. One will be for g prime of x being 0. Very nice. Only the numerator can be 0. So this is a critical number. The numerator is 0 when x is 0. The other possible source is when this is undefined. None. Because x squared plus 1 is never 0. It's a positive number always. So the only critical number is that. Yes?
Question.
Yes?
So would there be like any possible chance if, let's say if g, can there be two critical numbers?
Yes.
Like the undefined
Yes.
and the
Yes.
first one?
Yes. Or this could be a quadratic equation and we will get two critical numbers. Yes. Absolutely. We can find functions with critical numbers coming from both sources, and also from one of them. For example, if this happens to be a quadratic, I'll have two solutions. It wasn't quadratic, so I only had one solution. Very good question. Thank you. Good. So do we choose the last type, 33 or 34, or we move on?
Can you do one more?
Yes, yes, yes. Anything, please choose. Anything.
35.
30. We're not there yet.
Oh, we're not. Okay. Then,
Yeah.
Can you do 29?
Yes, we can do 29. So I wanted you to choose either 33 or 34 because that's the last type. Let's continue with 29 first. So g of x, 4x divided by x squared plus 1. You know me. My function is a constant times whatever. I'm not going to involve 4. 4 can patiently wait. So I will determine g prime, 4 in front. Top function prime is 1 minus top times the denominator prime over the denominator squared. I know it's extremely tempting, but please make sure you do not simplify this with this. That will be a tragedy in the making. So 4. X squared minus 2x squared is negative x squared and plus 1 over x squared plus 1 squared. And yes, I refuse to work with a negative leading coefficient. So now critical numbers may come from two sources. Either g prime of x to be 0. A fraction is 0 when the numerator is 0. And we know there will be 2. You either factor or take the square root. I didn't mean that. I meant x equals plus or minus 1. And the function may have critical numbers coming from f prime being undefined, in this case g prime being undefined, which is not the case. X squared plus 1 is never 0. So these are the critical numbers. Okay, any questions on this?
Is there a reason why it's always the numerator for g prime equals 0?
If it's a fraction can be 0 only when the top is 0. If the denominator is 0, we are in big trouble.
Okay, thank you.
So let me clarify what I was just saying. If I have a divided by b set equal to 0, because that's what I need to do, only a can be 0. If b is 0, the whole thing is undefined. It will be a tragedy. The function goes away. So if I ever have to solve a fraction equals 0, only the numerator can be 0. Or cross multiply. When you cross multiply, that's what you get. A equals 0. Put this over 1. A times 1 is A equals B times 0, which is 0. Good. Do we want 33 and 30 or 34, or we move on? And I reached 16.